Hi everyone. So today we are doing F2, which is basically functions. Now let's see, is a lengthy topic. There are a lot of things that we are going to discuss here. One is obviously what functions are, how do we define them, what are the characteristics and so on. Then there comes a few definition part, three definitions of domain, codomain and range. The third part is various types of standard functions, part one, part two. The next one is composite function, which is again very important because usually questions that you will see are from composite functions. And at the end, these are again standard functions as well, which are the last part, which is even and odd functions. So pretty long topic. Let's start with the basic. What exactly is meant by function? So function, in simple words, in layman's language, if somebody has to explain this, it is probably a kind of a machine. Uh, which has two sides. On one side, input goes inside, uh, the machine processes something on that input and gives you out the output. For example, in this particular scenario, the machine is going to perform an operation of 2x plus 3. Okay, suppose there is an input x which is going inside and there is an output y which is coming outside. So if that is the case, input x coming in as a input and output y coming out. Suppose let's take some examples. Suppose if x is 1, you get 5 as output. If x is 2, you are getting 7. X is 10, you are getting 23. X can be a square, you will get 2a square plus 3. So the point is, this input x can be anything. It can be positive number, negative number, integer, decimal, fraction. For all you know, it can be a variable as well. For example, a square. Whereas this output, it cannot be anything. If you observe very carefully, actually it depends on what the input is. For example, whenever input is 1, only then the output is 5. If the input is 10, the output is 23. So what we come to know from here is that input is always the independent variable. It has no control. It can assume any value or variable as well. Whereas the output is always the dependent variable. So output is dependent, so we can say that y is dependent on x because y is the output, and that means it is, in better words, it is called as y is a function of x. So y is dependent on x, hence y is a function of x. That's the definition. Now taking this forward, this is how you represent that y is f of x and a function of x. Suppose this operation, it may not be always 2x plus 3. It can be any other operation as well. For example, some other function is there, some other machine is there, which is performing a different operation of 2x square plus 3. In that case, what do we do, or how do we simplify this is that suppose again input x is going, output y is coming. You start substituting the values. X is 1, output is 5. X is 2, output is 11. X is minus 2, output is still 11. X is 10, output is 203. X is a square, output is 2a raised to 4 plus 3, and so on. So one interesting thing here that you can actually observe, which is that whenever x is 2 and when x is minus 2, you see that exactly same value of output that you are getting, which is 11, which is very much okay, which is very much possible, because it entirely depends on what your function is all about. So here f of 2 is equal to f of minus 2. Now, how do we define exactly? The important criteria for function to be is that a function relates each element of input with exactly one element of output. So one element of input x should always track with one element of output y, exactly one element. And that is a basic definition of function. For one value of input, there has to be only one value of output only. If for one value of input there are more than one value of output, then that means it is not a function. Here in the first scenario, as you can see, one value of input, there is only one value of output. So this is a function. Y is a function of x. But if something happens for one value of input more than one value of output, it is not a function. This violates the definition, but vice versa is true. For example, we had just now seen that for output 11, there were two different values of input for the same output of 11. There were two different values of input, one is 2 and one is minus 2. So it really depends on how you are looking at. Now, following are the few examples to identify whether they are functions or not. Very simple thing. You keep solving them. For one value of input, if you get just one value of output, then that means it is a function. This one, similarly, for one value of input x is equal to 3, you are getting output get two values because of the square nature, plus and minus 4. It is not a function. Same thing is happening for the third one. For one value of input x is equal to 9, you are getting two values of output plus and minus 4. It is not a function. So y is not a function. But if you look at it from the other perspective, like from y's perspective, you will realize it is a function. From x's perspective, x is a function of y. So when we solve for x, you will substitute y is equal to 3, which is going to be the input now. And when you substitute y is equal to 3, you get x as 16. So for one value of input, you are getting one value of output. That means it is a function. So y is not a function of x, but x is a function of y. Then the other way to verify whether a given expression is a function or not, apart from the solving way, is something called as a vertical line test. It's a very simple thing. As the name suggests, you first have to draw the graph of the given equation, whatever is the standard graph of the equation, and then you just have to draw a vertical line in that graph. For example, the first example, y plus 3x is equal to c. It's a straight line, something like this, linear equation, standard form. So it's a straight line. Now once you draw the graph, you just have to draw a vertical line. So suppose there is a vertical line, and when you trace that vertical line back on the respective x and y axis, what you see is that you are getting just one value each, and that actually tells you that for one value of input there is just one value of output. You can do that at anywhere on the entire graph. So suppose you take any different point, still you will get the same answer. So the first equation is a function. This is a graphical way of proving that it is a function. Similarly, when we do it for the second, the equation is a circle ka standard form, x square plus y square is equal to r square. So the graph will be a circle. And now when you draw a vertical line in this graph, you will actually surprised to know that for one value of input, because of the nature of the graph, you are getting two different values of output, plus or minus. And that means for one value of input, you are getting more than one value of output. That means it is not a function. And again, you can do that anywhere on the entire graph. There is no restrictions for that, and you will keep on getting the same conclusion. So this is not a function, clearly. So that's the first part, folks. How the functions are defined, what are some basic properties associated with them, and how do we verify or prove whether a given equation is a function or not, using both solving as well as graphical approach. So this theory is very critical. The second part is the three definitions: domain, codomain, and range. One simple examples they have given. Don't focus on that right now, the tabular form. Simply just remember the definitions because they are not very difficult. So the first one is domain. So domain are all the values of input. Domain is defined as set of certain values that input x can take. Similarly, codomain is set of all values that output y can take, as you can see at the bottom side of the slide. Set of all values that output y can take, f of x can take. They are called as codomain. Then what is exactly range? So codomain is all values of output y. Domain is all values of input x. So range is even specific values of codomain, which is output y, which are defined from the pre-decided domain, as in input. So for example, if you observe that malaria has a major symptom as fever, measles has a major symptom as rashes, and typhoid has a major symptom as fatigue. So codomain are going to be all five values of output that you can see in the red circle, but range is the three values of codomain, which are the specific ones: the fever, the rashes, and the fatigue. So in short, if I want to define range, range is set of values that y can take based on the defined domain. Based on the defined domain is the main criteria. So simple three definition, and that's how you should remember. This example is just a helping hand to you so that you understand in a very, very clear manner. The next part of this topic is basically few of the standard functions that we are going to explore now. The first one is identity function. Identity function is basically y is equal to x. Whatever is the value of input, same will be the output. So when you suppose you take x is equal to 3, the input is 3, the output is also 3. You take input as -3, the output is also -3. You take input as 5.7, output is also 5.7. You get input as -5.7, you will get output as -5.7. This is exactly what is identity function. It's copy paste, we call it in simple words. No mehnat at all, just whatever is the input, just give that as the output. No processes involved whatsoever. Now when you try to think of a graph plotting of this identity function, you realize that both x and y's values will be the same, exactly the same. The sign is same, the magnitude is also same. So when you think from that perspective, you'll realize both will be either positive, both will be negative, and that means the graph will be in both the quadrants, quadrant number 1 and quadrant number 3. So it will be a straight line passing through origin, something like this, making an angle of 45 degree with respect to the positive x-axis. So this is how the graph of a identity function will look like. The second standard function is a constant function. So constant function is even further lazy. It says that you already predefine an output that you want, and irrespective of whatever input that we get in the machine, we will keep on showing the same output. So suppose y is equal to k predefined, which is 3 in this example. So whatever is the input, you are going to get the output fixed that you have already decided, which will be 3 in all cases. So x is 3, output is 3. X is -3, output is still 3. X is 5.7, output still 3. X is -5.7, output is still +3, whatever you pre-decide. Graph perspective, obviously, y-axis value is same, which is 3 in this case. It will be a parallel line. It will be a straight line, sorry, it will be a straight line parallel to x-axis, something like that. So this is what the constant function is. The third standard function is an absolute value function, or we also call it as modulus function. Everybody know how it is defined now. By now you should know definitely. Distance of x from origin, and modulus we also know, we just change the sign. So 3 ka mod is 3, -3 ka is also 3, 5.7 ka 5.7, -5.7 ka +5.7. And when you try to plot the graph, you will realize that a graph is a V-shaped graph increasing on both the sides in the first and the second quadrant. Why in the first and the second quadrant? Because you observe the values of y, they are always positive, and y is positive on the upper side of the graph. So the graph will always stay on the upper side. It will never come on the lower side, because at the lower side y will be negative. These are all logical points why it is like that. And obviously the way modulus has been defined, you remember all, distance of x from origin, and that means area under the curve. In this case it will be a triangular shape. So this is how the graph of modulus function or absolute value function will be looked like. The next of the standard functions are interesting ones. One is integer value function. In that we have two categories actually. One of them is greatest integer function, and one of them is smallest integer function. So let's first understand how it is defined. So it is defined y is equal to square bracket x, which means, very critical definition, greatest integer less than or equal to x. Greatest integer less than or equal to x. Now let's consider a few examples, and number line will help us drastically in that. But let's do it very slowly. So suppose input is 2.7. The first thing we are going to figure out is integers which are less than 2.7. Integers which are less than 2.7. And when you observe like that, or when you think like that, you realize there are many such integers which are less than 2.7. 2, 1, 0, -1 and so on. Basically you have to go on the left side of the number line. But look at the wordings, greatest integer function. And because of the word greatest, so there are many such integers which are less than 2.7, but the highest among them will be +2. So the output of this will be +2. Similarly, let's do more examples. Greatest integer less than or equal to 4.5. So 4.5 से बहुत सारे integers छोटे होंगे, but उनमें से सबसे बड़ा होगा +4, इसीलिए इसका output will be +4. On the negative side, you will still go on the left side of the graph. So -1.2 से less वाले integer -2, -3, -4 and so on. But इनमें से सबसे greatest will be -2. Hence -1.2 का output will be -2. So this is how the values will be taken care of for the decimal numbers. Suppose you have an exact value, for example, greatest integer of 3, greatest integer less than or equal to 3. Because of the word equal to, when you have the exact number, the same becomes your output. So for this one it will be 3. For -3 it will be -3. So these are few examples, and these all values will help us to realize how the graph will be. It will be a very interesting graph, because you realize for certain set of values the output is constant, and then for one particular value all of a sudden it changes, and then it stays there for a while, and then again it changes, So it's going to be a step function, we call it. Now step function also looking wise very interesting, and this is how the graph will look like. So this is the final graph of a greatest integer function. The first of the integer value function. The second one is smallest integer function. It is denoted as curl bracket x or round bracket x, defined as smallest integer more than or equal to x. Smallest integer more than or equal to x. Again, let's consider few examples. So 2.2. So integers which are more than 2.2, many more such integers, 3, 4, 5, 6, 7 and so on till infinity. But out of them, we are asking for the smallest one. So when you think from that perspective, the smallest one in the list is obviously +3. So the output of this will be +3. Same applies for the other ones as well. 3.5 ka smallest integer is 4. More than or equal to 3.5 is +4. So in simple words, this basically means you have to go on the right side of the number line, whichever is the first integer, you are going to mark. Sorry. For -3.5, it will be -3. Sorry. Now, same will happen when you have the exact number. For example, 2. For 2, you will have exactly 2 as the value. For -4, you will have -4 as the output. You guessed it correct. Now again you realize that this has to be a step function, because again for certain set of values the values will remain constant, and then all of a sudden it will change to a different value. So this will be also a type of a step function only, but very slightly different than the previous one, which is the greatest integer value function ka graph. So the smallest integer value function ka graph will look something like this. in a way a step function only, but ever slightly different than the previous one. Okay, the next part is basically quadratic function. We know the graph y is equal to ax square plus bx plus c standard form. Graph will be a normal parabola. Delta is greater than 0. Roots are real and unequal. Delta is equal to 0. Roots are equal to 0. Delta is less than 0. Imaginary roots. Then you have another quadratic inverted graph when the value of a, that is coefficient of x square, is negative, and you get a inverted parabola. Same three conditions that we had seen just now. Delta is greater than 0, real and unequal roots equal to 0, real and equal roots, and less than 0, imaginary roots. So quadratic function is also one type of a standard function only. Next part is actually even more important, which we call it as composite function. Let's first see what it is. So you know the definition of function. There is a machine. Suppose there is a function f of x, which has a job of performing an operation of x plus 3. So suppose some input goes inside, which is x, and some input y, which comes outside, which we call it as f of x. Now what we will do is we'll connect that output y of the first function, which is f of x, to a entirely different function, suppose g of x, which is doing an operation of x square, and we will get another different output, which is y1. And this complex arrangement is called as composite function. So basically this cycles can be keep on continuing till infinity, where suppose this y1 output can be connected to an entirely third or different function, which is suppose h of x as the input, and then you further proceed, and then suppose you get a output y2 from the h of x as a third function. Now how do we write this down? First of all, so here what exactly we are doing is, if you observe, we are replacing g of x ka input x by f of x. So the input is not x anymore for g of x, but it is f of x, which is the output of the first function, which was f of x. So we will write it down as g of f of x. So if you observe very carefully, and this is where the solving part will be very handy, that what we are doing ideally is we are replacing g of x ka x by another new input, which is f of x. So this is how it is written. It is pronounced, or it is called as g of f of x or g o f of x. Both mean one and the same. The reason you should know both the interpretation is that examiner might try to trick you in this, and you would not remember, or you would not understand what exactly he or she is trying to ask you. And you know, despite of knowing the answer, you may not able to get it right. So be very clear and be very thorough with all such small things also, because they are equally important. So a function of function is called as a composite function. That's a main idea. Now for all you know, this entire system could have been reversed. Okay, as in f of x need not to be the starting point. It could have been g of x, and then f of x could have been the exit point. For example, if we reverse this everything, what we get is, suppose g of x has a input x, and then you get an output y, which is x square apparently, and then this output y, which is g of x, is connected as the input to the new function f of x. So f of x has a job of doing x plus 3, but instead of f of x ka x, what are we saying is, we have to now replace this x by g of x. We have to now replace this x by g of x. So you will get the output as f of g of x, which can be also called as f o g of x. So both are one and the same things again. So you should clearly remember all these kinds of representation, so that you would not make the mistake. This, as I said earlier also, this complex set of functions is called as composite function, which we in simple language called as a function of a function of a function of a function. The cycle can be continued infinitely without having to break it. The last part of this lengthy topic, which is even and odd functions, which is also one of the standard types of functions only. So let's first see the even function. So the important part of even functions is that the input changes the sign, but the output does not change the sign. As you all can observe here, if input is x, you are getting the output as f of x, which is still positive. And if the input is minus x, you're still getting the output as f of minus x, which is still the positive. So don't get confused. This inside x, which is always inside the bracket of function, anything which is inside the bracket of function is always called as the input. So you observe that the input का sign ही change हो रहा है, x and f minus x, whereas the output f of x is always going to be the plus one only. And when such thing happens, the function is called as an even function. For example, the statement input changes sign, output remains the same. The function is called as even function. This is a category, actually broader category. There can be many such functions which can be classified as the even functions. For example, one very simple example is the square function. You exactly know when we square, the value, the number is positive or negative, doesn't really matter. The answer is always, after squaring, the answer is always positive only. And another very famous example would have been a modulus function. Modulus function, you know, input can be either plus or minus, but output will always be positive only. So modulus function actually is a standard function, but it also comes under a broader category of even function classification. So square function, modulus function, these can be the two basic examples of even function. But mind you, any function which satisfies this criteria, input changes sign, output does not change sign, or output remains the same, can be called as a even function. There's a theory point. How does the graph looks like? Obviously, the graph is a slightly complicated graph, and it will look something like this. So it will be a graph which will be symmetric across y-axis. Symmetric across y-axis as in mirror image, basically, as you can see. So this is how the graph of the even function looks like. It is symmetric across y-axis. Then the next one is a odd function. Now odd function, obviously it has to be exactly opposite of that of even function. Input changes sign, output also changes the sign. Input is x, output is positive. Input is minus x, output is also minus x. Theory, input changes sign, output changes sign. Few examples of odd functions. Obviously the negative function, by default negative function, or cubic function. We know 2 ka cube is 8, but minus 2 ka cube is minus 8. So negative function or cubic function can be the two easy examples of odd functions. The graph is slightly even complicated than the even functions, and it is not only just symmetric across y-axis, but it is also symmetric across x-axis. And how do we draw this is that first you take the water image of right side portion. Water image as in it will be reflected downwards, and whatever is the water image, that means it is symmetric across x-axis. You have to take the mirror image of that portion, and when you take the mirror image, that means it is symmetric across y-axis. So in short, the graph of the odd function is drawn like this. That's the main idea behind this, but technically it is symmetric across both x and y-axis. So these are the different types of functions that we should be aware of, and the theories associated with them. Mostly from the solving perspective, you will see questions based on composite function, because that is where simple errors or the calculation errors will happen.
The first one.
For the following table, we have to find the value of y when x is either 8 or when x is 100. So clearly when you observe, there are 7 values of x and y which are given to us. So to find out the value of y when x is 8 and when x is 100, we are going to require a direct expression in terms of x and y, basically the original function, so that we can just simply substitute the value of x as 8 and x as 100 in that, and we'll get the answer for the y respectively. But now the whole challenge is how do we find out that entire original function, and this is the process you'll have to remember going forward. So the values of y that you already have with us, let's try to take the difference between them. So 18 minus 12, 6, 28 minus 18 gives you 10, 42 minus 28 will give you 14, 60 minus 42 gives you 18, and so on, so forth. So clearly this difference is not constant, which is called as the first order difference. So what we will do, we'll do the second order difference. Now second order difference simply means difference of this difference. So 10 minus 6, 4, 14 minus 10, 4, 18 minus 14, 4, and so on. And what you observe is that the second order difference is constant. So whenever such thing happens that the second order difference is constant, the function will be of the type of a quadratic function. If the first order difference would have been constant, it would be of the type of a linear equation. If let's say even this second order difference is not constant, but the next difference after this, which is the third order difference, is constant, then the function would be of the cubic equation type. So these are the informations that you will have to remember going forward. So here obviously the second order difference is constant. So the function is of the quadratic type. Quadratic general form ax square plus bx plus c. Now again, to get the original function, we need the three values of ABC. Now how do we get that? So we'll have to do the solving here from the respective values of x and y. So substitute x as 1 here, and whenever you do that, x is 1. So the expression will be a plus b plus c, and for that the value of y is 12. Similarly, when you substitute x as 2, the expression will be 4a plus 2b plus c, and for that the value of y is 18. And because we have the third variable as well, so we'll require the third equation as well. So try to take the values simple as much as possible. You can do any three values, but obviously since you are the one who's going to calculate this all, try to make things as simple as possible so that you don't do the error when it comes to the calculation. So third expression, substitute x as 3, you get 9a plus 3b plus c is equal to 28. Three equations, three unknowns, simultaneously solve them, you'll get the value of ABC. When you get the value of ABC, which turns out to be 2 and 0 and 10 respectively, substitute that back in the original expression and you get the original function. So the original function is 2x square plus 10, that is your original function. Now, once you get the original function, calculating what we need is not difficult at all. Now, in this particular expression, we'll have to substitute x as 8 and x as 100. So, whenever we substitute x as 8 into x square plus 10, you get the value of y as 138. And whenever you substitute x as 100, the value of y that you get is 20,010. So, option 2 for the answer for the first question. And this is how you solve that. Second one, pattern finding. F of n of x is equal to f of n minus 1 x, and f of x is given as 1 by x. Then find the value of f of 243 of 2063. Now how do we solve this? In the original expression, they have given f of x. Yani it is f1 of x which they have given. And that value is 1 by x. So you have the value of n as 1 here. So obviously in this main equation, whenever you will start solving, you are going to take the value of n as 2 because you have the value of n as 1 because you have the value of f1 of x. So take the value of n as 2. So you get f2 of x. Substitute this value of n as 2 in this as well as on the right side as well. Whenever you substitute in this equation n as 2, you will get f of f1 of x. Now f1 of x we already know, which is 1 by x. So what does that means is the function does what? Whenever is your input is x, the output is 1 upon x. But now we are not supposed to find out f of x. We are supposed to find out f of 1 upon x. And f of 1 upon x, the input is not x anymore, but it is 1 upon x now. So obviously the function does the inverse or the reciprocal of the input. So if the input is 1 upon x, the inverse or the reciprocal of that will be x. And that gives us the value of f2 of x as x. Again, f2 of x is x, substitute n as 3. Whenever you substitute n as 3, you get f3 of x. f3 of x will be f of f2 of x. f2 of x we have already calculated, which is x. So you are supposed to find out f of x. f of x, the answer is 1 upon x. So f3 of x ka value is 1 upon x. f3 of x ka value is there. Let's do one more last iteration so that we can confirm the pattern. Let's substitute n ka value as 4. So we get f4 of x, which is f of f3 of x. f3 of x is 1 by x. f of 1 by x, the answer is x. So the value of f4 of x is x. So 4 values are sufficient for us to confirm the pattern. And when you observe the pattern, whenever the power is odd, the input is x, the output is 1 upon x. Yani inverse of that, reciprocal of that. But whenever the power is even, f2 of x and f4 of x, the input is x and the output is also the exactly the same, which is x only. So all you have to do is observe your question where the power is either even or odd. So clearly 2063, the power is odd. So if the power is odd, whatever is the input 243, the output will be reciprocal of that, which will be 1 upon 243. Answer option first in terms of pattern finding. So it's like step after step monotonous solving. You'll have to know. And even if you, let's say, don't realize and you substitute n as 1 to begin with, immediately you will realize, because on the right side when you substitute n as 1, you will have f0 of x, and f0 of x there is no value. So immediately you will go back and correct that, and instead of n as 1 you will start with n as 2, so that you have f1 of x which you can utilize later on, and so on. Third one, they have given two functions f of x and g of x, which are defined as f of x is equal to g of x minus 1 and g of x is given as 1 upon x square minus 1. So they have only given the function g of x, which is 1 upon x square minus 1. They have not given f of x directly, but they have given us the way to find out f of x based on g of x. So to find out f of x, what you will have to do is, whatever is the input of g of x, which is x apparently, originally, that you will have to replace by x minus 1. So basically, you just have to do the small change in the function g of x, that instead of the input x, wherever there is x, you are supposed to substitute x minus 1 in that place. And whatever the new function that you get, that will be called as f of x. So this part is something that you should realize when you read the question. And then the final question is, how many times do the graphs of these two functions intersect in the coordinate plane? Now this is a very classic technical question, that how many times the graph will intersect, the equations will meet each other, how many common solutions, etc., etc. All these 3-4 things mean one and the same, that you are supposed to equate both the things, whether it can be two functions, whether it can be two equations, and so on. So how many times do the graphs of these two functions intersect? Yani we'll have to equate both the function. Yani f of x is equal to g of x. That's it. G of x we know, 1 upon x square minus 1. F of x we know how to write. Replace g of x ka input x by x minus 1. So you get the function as 1 upon x minus 1 the whole square minus 1. You are just simply replacing instead of x, x minus 1. That's it. That is something you should realize. That's all. Do the solving. You will get the value of x as 1 by 2. 1 by 2 means we are getting only one value of x, and that means this is the value of x, which is 1 by 2, in which the graphs of these two functions f of x and g of x will intersect each other in the coordinate plane. So the question was how many times? Obviously, they will intersect only once, and this is that point x is equal to half where they will intersect each other. So this is how you can solve that. Remember the language: common solution, intersecting point, intersecting, how many times do they intersect. All you have to do is equate both the things. Fourth one, another pattern based questions. These few are: f of x plus f of x is equal to x square minus 3x plus 5, and f of 1 is given, which is 2. We have to find the value of f of 34. So because we have the value of f of 1 in the original function, we will substitute x as 1. So whenever we substitute x as 1, the original function becomes f of 1 plus f of 1. And f of 1 is something that we already know, which is 2. So substitute that here. F of 1 ke jagah pe substitute the value which is 2, which is given. So it becomes f of 1 plus 2, which is f of 3. So whenever you start substituting x as 1, you are going to get the value of f of 3. And because you have substituted this on the left side, obviously substitute x is equal to 1 on the right side as well. So when you do all of this, you'll get the value of f of 3 as 3. Similarly, in the next step, now because you have the value of f of 3, so in the next step, substitute the value of x as 3 again in the original function. Whenever you substitute x as 3, this will be your original 3 is again 3, which we have calculated in the previous step. 3 plus 3, it becomes 6. And substitute on the right side as well x as 3. After that calculation, you get the answer of f of 6, which is 5. Similarly, again, we have f of 6. So in the next step, substitute x as 6 because of the continuity. So whenever you substitute x as 6, the expression becomes f of 6 plus f of 6. F of 6 we already know, it is 5. So it becomes f of 11. And for finding out f of 11, we have substituted x as 6. So substitute that on the right side as well. So right side when you solve, you will get 23. So f of 11 is 23. Last step one more time now. Because we have f of 11, substitute x as 11 in the original function one more time. So whenever you substitute f of 11, f of 11 is already known to us from the previous step, which is 23. 11 plus 23, you will get f of 34, which is what you were looking at. So for that, just substitute on the right side, x is equal to 11. So whenever you substitute x is equal to 11, you'll get your final answer, which is 121 minus 33 plus 5, which gives you 93 as the answer. So f of 34 is 93, option 1. Fifth one, a1 is given to us, which is 1. A of n plus 1 is 2 times a n plus 5, and n can be 1, 2, and so on. Then the value of a100 is equal to what? So because you have the value of a1, start substituting the value of n as 1. So whenever you substitute n as 1, you will get the value of a2. And for that value, for the value of a2, you have substituted n as 1. So the right side expression becomes 2 times a1 plus 5. a1 was known to us, which is 1. 2 times 1 plus 5, you get the value of a2 as 5 plus 2, which is 7. Because you have a2, substitute n as 2, you get a3. a3 will be 2 times a2 plus 5. a2 is 7. 2 times of 7, 14 plus 5, 19 is the value of a3. A3 is known. Substitute the value of n as 3. You will get A4. A4 will be 2 times of A3 plus 5. That is 19. 2s are 38 plus 5. 43 is the value of A4. And so on. So you're supposed to find out A100. Obviously, it is practically impossible to find out each and every value till 100. We'll have to do some pattern finding. So all the values, if you observe from the options, they are all represented in terms of powers of 2, and that is exactly you need to work out in terms of trial and error. So the first one, when you substitute n as 1, a1 1, so a2 will be 7. That a2 can be represented as 6 into 2 raised to 1 minus 5. 6 2s are 12. 12 minus 5, 7. A3 can be represented as 6 into a2 minus 2 raised to 2 minus 5. That is 6 4s are 24 minus 5, 19, and so on. So clearly you understand the pattern. Power of 2 is 1 less than the value of a that we are finding out. So for a4 it will be 2 raised to 3. For a3 it will be 2 raised to 2. For a2 it will be 2 raised to 1. So obviously for a100 it will be 2 raised to 99. So a100 ka value will be 6 into 2 raised to 99 minus 5, which is option 4. Purely pattern finding. Sixth and the seventh one, based on the graphical approaches, you'll have to mark these all options if this one of those equations hold true, basically. So let's do the working. The first one, two functions f of x and g of x is given to us. And how do I approach them is by understanding which quadrant they are in. For example, the first function f of x is in the first quadrant. First quadrant is where both x and y are positive. And g of x is in the fourth quadrant. In the fourth quadrant, x is positive, but y is negative. And after doing the analysis of that, only option 3 can a b holds true, where g of x is equal to minus of f of x. Actually, that minus sign should be on the g of x part because y is negative. But obviously, mathematically, it is very much possible to shift the minus sign from left side to right side, obviously without affecting the answer. The technically correct answer would have been minus g of x is equal to f of x, but based on the options that are available to us, this is the best choice after taking that minus sign from g of x to f of x. This is how you solve that. Exactly the same as the seventh one. F of x, g of x, two graphs again. F of x is in the third quadrant. Third quadrant, both x and y, both are negative. G of x is in the first quadrant, both are positive. So exactly opposite of this. So minus of my f of minus x is equal to g of x should be the answer, which is option D. Y is also negative. X, the input, is also negative. Whereas for g of x, because it is in the first quadrant, both input as well as the output, they are all positive. So option 1, which is D. Eighth one, f of a is given to us, which is 2 upon 2 plus a. What is the value of f of a? This is called as composite function. And whenever you come across such things, how do we attempt them? So you always start with the innermost bracket, which is f of a. And f of a is something which is 2 upon 2 plus a. So instead of f of a, substitute 2 upon 2 plus a. That's the change. So now your question is, now you'll have to find out f of 2 upon 2 plus a. And don't worry, it is exactly the same with a bit of solving as well, because original function, if you observe, the input is a. But right now the change that has happened is that the input is not a anymore, but it is 2 upon 2 plus a. So what you will have to do is, in the original place, whenever there is a, instead of that, you will have to substitute 2 upon 2 plus a. So that is what you are supposed to do. Whenever you substitute in the original function, what is that original function? This is that original function. In this function, what you are supposed to do is, instead of a, substitute this, because the input is not a anymore, it is 2 upon 2 plus a. And whenever you do that, you get the value as 4 plus 2a upon 6 plus 2a. And the last time, f of 4 plus 2a upon 6 plus 2a will be, substitute this entire thing one more time in the place of a, because now again a is not the input anymore, but it is 4 plus 2a upon 6 plus 2a. And after doing that calculation again, instead of a, substituting 4 plus 2a upon 6 plus 2a again in that equation, this is what you will get as the final answer, which is 2a plus 6 upon 3a plus 8, which gives you option first. Function of function, which is also called as composite function, if you remember. Ninth one, square bracket x denotes greatest integer less than or equal to x. Find the number of positive integral solutions to the following equation. So first, obviously, the definition is given already, but if you remember, I've told you already, whenever the square bracket x comes, and if it is from the reference point of functions, obviously it is assumed that it is greatest integer function that they are asking. So you should be very clear about the theory and the concept related to that. Normal bracket x or curl bracket x means smallest integer function. So be very careful about that. So let's do one by one. Let's consider only x upon 28. Suppose if I substitute x as 0, then this entire thing becomes 0 and the output will also be 0. If I substitute x as 1, then this becomes 1 upon 28, which is 0 point something. And 0 point something, the output will still be 0. If I substitute x as 27, so it becomes 27 upon 28, which is 0.999 something, but still not 1. And the output for that will still be 0. But the moment I substitute x as 28, this becomes 28 upon 28, which is 1. And the output of that will be 1. So clearly there is a pattern. The output will be 0 whenever x is 0 to 27. The output will be 1 if x is 28. Until when the output will be 1? Unless x doesn't become 56, because 28 ka double is 56. So output will remain 1 for the values of x from 28 to 55, 1 less than that. The output will become 2 if the x is 56, until where 28 3s are 84, 84 minus 1, 83. So from 56 to 83, the output will be 2. It will become 3 when x is 84, and it will remain like that till 111. And it will become 4 at 112, and so on. If you understand this pattern, automatically it becomes easy for us to figure out for the other one. Output will be 0 for x between 0 to 36. It will become 1 when x is 37 till x is 73. It will become 2 when x is 74 till it becomes 110. And for 111, it will be 3, and it will keep on being 3 till 143, I think. Because, sorry, 147, because at 148, it will be 4, and so on. So beyond this, they will never be equal. And if you remember, they were supposed to find out the common solution between two. And this is where it becomes very interesting. You'll have to equate both of the values, and you have to find out the common range for the x for both of them. So obviously common range will be when x is 0 to 27 for 0. Then for 1 it will be 37 to 55. For 2 it will be 74 to 83. And for 3 it will be only 111. And also the small catch, they were asking only positive integral solutions So you're not going to consider 0 as well. And these are the small things you'll have to be very, very careful about. So 0 cannot come here. 1 to 27 because of the words positive integers. Then 37 to 55, 74 to 83, and 111. You just have to count these values and add them up. 1 to 27, 27 values, 37 to 55, 19 values, 74 to 83, 10 values, and 101, one single value. The combined total of them gives you 57 common solutions for both of them. Answer option 5 for the ninth. These are the things you should be aware about as far as the greatest integer function is concerned, the concept and the theory. 10th and the last one, the value of a quadratic function f of x is negative for all the values of x except for x is equal to 2. F of 0 is minus 10, then find the value of f of 4. So clearly the quadratic function is negative. And if you do this with the graph, you'll get your answers very easily. So the function is negative, so it will be a inverted parabola. But the function is not entirely negative. It is not negative for only one value of x, which is x is equal to 2. So this is how the graph should look like, where it will just barely touch your x-axis at point 2. So that it is not negative only for this value, but it is negative for all the other values. And the quadratic function is a symmetric graph function. So it is like if I break this down from the center, it will give me two exactly equal halves. So f of 0 they have given, which is minus 10. F of 0 is the value of x, and 10 f of 0, yani that is the value of y. So basically the point is 0 comma minus 10. That is the point that they are asking. So 0 comma minus 10, the point will be on the y axis because the x coordinate is 0 and the y coordinate is minus 10. And they are asking the value of f of 4. F of 4, how we'll get f of 4? For that, we'll have to find out the value of y. And as I said, because the quadratic equation is a symmetric graph will be you cut it in between. Whenever you cut it in between 0 to 2, 2 units of distance, and 2 to 4 is also 2 units of distance. So when you cut that, you get the same value, that is f of 4 is also minus 10. So f of 4 is also minus 10 and f of 0 is also minus 10. So the value is minus 10 for f of 4, which is none of these, which is option 5. So this is the way to solve this question very easily with the help of the graph. So some bit of technicalities, if you are aware about the graph, things are going to be very easy for you. With this, we are done with functions. If you have any questions based